The metamorphosis of mineral, a journey into the heart of cement, from the foundations of our homes to the skyscrapers that pierce the clouds, a humble gray powder silently governs the architecture of the modern world. Cement. The primary building block of our urban lives, it is the second most consumed resource on Earth after water. Yet, few truly know the fabulous epic, the thermal and mechanical odyssey that transforms raw rock into this universal binder. Today, we invite you into the very depths of this colossal industrial alchemy, from the limestone cliffs to the gates of the construction sites of the future. Our narrative begins in an open-pit quarry, a true geological amphitheater. Here, limestone, a sedimentary rock laden with marine fossils and ancient memory, coexists with clay and sand. At dawn, titanic drilling rigs bore deep into the rock face. Carefully placed explosives unleash thousands of tons of material in a single blast, sending a cloud of ochre dust billowing into the sky. Immediately, giant hydraulic excavators, veritable steel mastodons, spring into action. Their buckets, large enough to swallow entire trucks, feed massive haulers whose wheels tower over a man. The roar of diesel engines and the screech of tracks crushing the shattered limestone set the rhythm for this first phase of mineral conquest. But this raw material, still too coarse, cannot yet reveal its secrets. It must first be reduced to rubble. Erratic boulders are swallowed whole by the primary crusher, a hydraulic jaw whose crushing pressure defies imagination. Amidst a deafening metallic cacophony, the rock is broken, shattered, and reduced to the size of gravel. This gravel then embarks upon a long rubber belt, a conveyor system that snakes for miles across valleys and hills, a mineral artery linking the quarry to the mother plant. Shielded with covers to contain dust emissions, these rubber freeways tirelessly transport the material toward its thermal destiny. Upon arrival within the plant's confines, the raw materials are stored in circular storage halls. A spectacular machine, the stacker reclaimer, deposits the rock in perfectly alternating layers, creating chevron patterns that a surveyor would envy. This preliminary homogenization is critical. The raw meal that results after passing through vertical roller mills or ball mills must achieve extreme fineness, an impalpable texture akin to talc. Under the pressure of rollers weighing several dozen tons, the rock is transformed into an ochre-gray powder. This is the raw meal, ready to be introduced into the blazing heart of the process. The raw meal now rises toward the preheater tower, a cathedral of sheet metal and concrete that dominates the landscape. Within this tangle of cyclones and ducts, the powder is suspended in a stream of scorching gases drawn from the kiln. In mere seconds, it goes from ambient temperature to nearly 850 degrees Celsius. This lightning ascent triggers an essential chemical reaction, decarbonation. The limestone, under intense heat, releases its carbon dioxide, a gas largely responsible for the industry's carbon footprint. The raw meal loses nearly a third of its mass, becoming more reactive, more voracious for heat, but it is within the rotary kiln, the beating heart of the plant, that the true transmutation occurs. This immense cylindrical shell, slightly inclined and sometimes longer than 100 meters, rotates tirelessly on itself at 1 or 2 revolutions per minute.
Limestone is quarried,
at its lower end, a flame resembling a
powder.
solar blowtorch, reaching a scorching 2,000 degrees Celsius, ignites the material. The raw meal, slowly advancing by gravity, passes through zones of progressively higher temperatures. It becomes liquid, viscous, and incandescent. Atoms of calcium, silicon, aluminum, and iron recombine, agglomerating into small, shiny gray-black spheres. Beneath the roaring flames, clinker is born, the precious, hard core of cement. A true artificial rock in a state of fusion. At the kiln's exit, this incandescent clinker, akin to a lava flow, must be brutally cooled. It plunges into a great cooler where giant fans blast cold air in countercurrent. This thermal shock is decisive. It freezes the clinker's crystalline structure, granting it its exceptional hydraulic properties. The superheated air recovered during this cooling is recirculated into the kiln, optimizing combustion and reducing energy consumption. This virtuous circle of modern thermodynamics embodies the cement industry's relentless quest for energy efficiency. Once cooled, the clinker is stored beneath immense domes or in vast hangars. It resembles volcanic rock, hard and angular. To become cement, it must undergo the final grinding. In gigantic ball mills, truly giant rotating drums filled with thousands of steel balls, the clinker is pulverized into powder. A pinch of gypsum, just a few %, is added to regulate the setting time. The deafening roar of grinding media crushing the material resonates like an infernal forge. When the drum finally stops, a fine, gray, silky powder flows out. Portland cement, the culmination of our journey, the elixir that yearns only to meet water to spring back to life and harden for eternity. Before leaving the plant, every batch undergoes a battery of stringent quality controls. In laboratories resembling surgical suites, robotic analyzers and X-ray fluorescence spectrometers hunt for the slightest chemical variation. Pastes are mixed, gauged, and tested for compressive strength. The consistency of the results is the signature of the future structure's reliability. Whether it be a motorway bridge or a hydroelectric dam, the finished product then reaches its final destinations. It is packed into multi-layer paper bags by ultra-fast rotary packers, or loaded in bulk into impressively voluminous tanker trucks. From maritime terminals, cargo ships carry this gray powder toward the shores of the entire world, fueling the rampant urbanization of sprawling megacities. However, this titanic epic comes at a cost. The cement industry, responsible for roughly 8% of global CO2 emissions, today stands at a critical crossroads. Faced with the climate emergency, it is innovating. Alternative fuels use tires, biomass, and plastic waste now feed certain kilns. Carbon capture, the use of hydrogen, and the development of low-carbon cements, incorporating blast furnace slags or fly ash, are shaping the contours of tomorrow's cement. The industry is reinventing itself, marrying the durability of our infrastructures with the preservation of our environment. Thus, from the roar of explosives to the impalpable softness of powder, cement remains far more than a simple material. It is the geological narrative of our Earth, heated, crushed, and transformed by human genius.
Optimize the feed on Unit 4.
From Roman aqueducts to futuristic skyscrapers, it embodies our quest for eternity, the metamorphosis of mineral into shelter. This gray powder is the silent link uniting our distant past to the vertiginous construction sites of our future, the invisible bedrock upon which our civilizations securely rest.